Okay, we will have a very short class today. So we were, am I audible? Anyone, please respond.
Yes,
Yes,
sir.
sir. You are audible.
Yeah, yeah. We were reviewing normalization theory. So we have seen that normalization is the process by which we try to reduce the redundancy present in a database design. So we have seen that given a problem or a given a system, people can come up with the different designs. When you are comparing or evaluating the designs, one parameter on which you can evaluate or make a comparison is actually the amount of redundancy that is present in the design. So more redundancy means more wastage of memory, and not only that, it brings a lot of anomalies. So anomalies during insertion, deletion, updation, etc. So in general, it is always better to reduce the redundancy, and practically it is impossible to eliminate the redundancy. So even though the design theory of databases or normalization theory says that we should go for ideally one copy for one piece of data, that may not be always possible. So we think of or we target at less amount of redundancy or less redundancy. So we have seen that there are different forms of normal forms. A normal form is actually a qualitative level in which a particular database design can be. As indicated in this diagram, so as you go high in the normal form, or the number of, you may be going high in the number of tables in a given design, and then the redundancy level will come down, and of course the complexity will go high. If you are splitting on a table, or you are splitting a design which is having 3 tables into a design, an equivalent design, where you have 15 or 20 tables, definitely the redundancy can be reduced, smaller tables, but what will happen is the complexity of the design will go high. Understandability will also come down. If you have only one table or 2 tables, you will be able to understand what exactly the table represents. But if you are having 20 tables or 25 tables, then it will be complicated design. But in general, if you are targeting a redundancy by way of splitting a table into smaller tables, you are actually increasing the complexity at the cost of reducing, while you are reducing the redundancy level present in the table. So this diagram indicates that all relations which are in 5NF are automatically in 4NF, or all 4NF relations satisfy the condition of being in 3NF. 3NF relations are satisfying the conditions of not only 3NF, but they are also satisfying the conditions of 2NF and 1NF. So we have seen that this particular relation is not in first normal form, but because you have multiple values here in other name column and other form column. So we have seen how that can be split up, or how that can be divided into 2 smaller tables where you have no redundancy. You have redundancy, but you satisfy the condition that all underlying domains contain only atomic values. A relation is said to be in first normal form if all the underlying domains contains only atomic values. Now we have seen regarding second normal, we have seen the concept of functional dependency. So what is the idea of introducing FD or functional dependency? Anakha, what is the importance of functional dependency?
Hello, sir.
Yes,
Sir, functional dependencies actually explains the meaning of the table and the column.
okay, very good. So functional dependency is actually formal notation, or this is actually the formal way of representing the meaning of a table. Okay, so how name and roll number are related, or how name and age are related. Can a student have multiple roll numbers, or can multiple students have the same name? Such things are actually explained formally using functional dependency. Or as I have said, semantics of the data are expressed in terms of FDs, in terms of the concept of dependencies. It can be either functional dependency, or it can be multi-value dependency, or it can be even joint dependency. Okay, so we have seen different examples for functional dependency. So we have also seen regarding full functional dependency and partial functional dependency. A functional dependency X determines Y is said to be full if Y is not dependent on any proper subset of X. So here we can say that here we don't have revision number, paper number. So look at this particular FD. Revision number, paper number determines author, commission, program, committee, or date, rating 1, rating 2, rating 3, rating 4, rating 5. So this functional dependency is said to be full. What is the condition for that? Agninijit, when we can say that the functional dependency revision number, paper number determines the rest of the attributes. This is a full functional dependency. Agninijit? Agninijit? You are not responding. Your mic is on. Agninijit, say something. Are you listening? Abhinijit. Abhinav.
Yes, when revision number and paper number are candidate keys, then we can say that this functional dependency is complete, full functional dependency.
Okay, suppose this other commission, or say the program committee, second attribute is dependent on paper number alone. Will this be a full functional dependency?
No, sir. In that case, it won't be a functional full functional dependency.
X determines Y is said to be a full functional dependency if Y is if and only if Y is dependent on X and not on any proper subset of X. All right. So we have seen that in second normal form. So the condition is for a relation to be in second normal form. First of all, the table should be in first normal form, and all non-key attributes in the table must be functionally dependent on the entire primary key. That means all non-key attributes should be fully functionally dependent on the primary key. Then only we say that the relation is in second normal form. The first case, first normal form, it was only talking about atomic values, but in second normal form, all non-key attributes should be fully functionally dependent on the primary. So we have seen examples for that. Then we have seen regarding third normal form. So in third normal form, what is actually the condition? Agrijit? Agrijit? What is the condition for being in third normal? Agrijit, you can type the answer on the chat box. Don't try to play around. Abhirijit? Now transitive dependency of what? Now transitive dependency means what? Abhirijit? Okay, it is wrong. Actually, the all non-key attributes should be non-transitively dependent on the primary key. All right. So the non-key attribute should be non-transitively dependent on the primary key. That is actually the condition for a relation to be in third normal form. First of all, it should be in second normal form, and non-key attributes, that means those attributes which are not part of the key. So that is very important. All non-key attributes. That means if a particular attribute is part of a key, it is exempted from the condition of being non-transitively and fully functionally dependent on the primary. All right. So we have seen examples for that. And we have also seen that if a relation is at least in third normal form, in general, database design will be accepted, or it is a reasonably good level of normal form. If you have reached up to, or if you can normalize up to third normal form, by and large, database designers go ahead with 3N. But if there is more redundancy, then people go for what do you call higher normal forms like BCNF, 4NF, and even 5N. All right. Okay. So we have seen examples of 3NF relations. So we have seen different examples and how they can be normalized to 3NF. Now BCNF, it is actually a normal form which is defined by Boise and Cord, and it is actually defined independent of other normal. That is, when you define 3NF, you say it should be in 2NF. And when you define 2NF condition, you say that it should be 1NF. So such a criteria is not there in the case of BCNF. In the case of BCNF, it is stated independently, irrespective of, without any explicit reference to 3NF, 2NF, etc. Okay, that is one difference. And second difference is that second important point is that all BCNF relations are automatically in 3NF relations, but all 3NF relations need not be in BCNF relations. BCNF form. So it is in BCNF, it does not allow dependencies between attributes that belong to candidate keys. Remember, the conditions of non-transitive and full functional dependency are applicable for non-key attributes in the case of 3NF. All right. But in the case of BCNF, that condition is not relaxed only for non-key attributes. It is applicable for all attributes. Even if a particular attribute is a part of the key, part of a candidate key, those attributes should also satisfy the condition of non-transitive and full functional dependency. That is actually the improvement of BCNF over 3NF. So the third bullet is very important. Third normal form and BCNF are not the same if the following conditions are true. That means the table is having two or more candidate keys and at least two of the candidate keys are composed of more than one attribute. So BCNF is applicable or it is found successful in context where there are more than one candidate key, more than or there are at least two or more candidate keys and the keys are not disjoint. That means those keys are overlapping. So the composite candidate keys share some attributes. That means the candidate keys are overlapping and there are more than two keys, more than one key, and they are overlapping. Then at least two of the candidate keys are composed of more than one attribute. That means there should be composite attributes or there should be more than one attribute in the functional dependency or in the key. In such cases, BCNF is found to be better than 3NF. A three attribute relation is given here: city, street, and pin code or zip code. So here there are two candidate keys, city and street. If you say the city and street, you can tell the pin code or the zip code. If you tell the pin code and street, you can find out the city name. So there are two keys and you can see that these keys are having more than one attribute and they are overlapping in nature. So you have street attribute common in both the keys. Okay. So here no non-key attribute, there are no non-key attributes which are not transitively, fully functionally dependent, etc. So it automatically satisfies the condition for a relation to be in 3NF. So are there any or is there any redundancy present in this particular table where you have city, street and zip code? Do you find any redundancy? This is actually third normal form. Are there any redundancy, Vishal?
Yes, sir.
What is the redundancy?
Sir, sir, I think city to zip. Sir, from city to zip code and zip code to city.
Now, what is the redundancy present?
Sir, transitive.
No, I mean redundancy. What is the duplication coming here? Chedana? Chetana. Absent. Damira. Damira Tarun. Okay, Devendra.
Zip code to city, sir. Dependency, sir, as the zip code is not a candidate key.
Louder, please, Devendra.
Okay, sir. Wait, let me. Okay. Hello. Hello.
Yeah.
Actually, sir, the redundancy is a zip code to city dependency, as the zip code is a not a candidate key. So there might be a duplicacy present in this dependency. Zip code to city, sir.
Yeah, actually, in a city, there can be many streets. In which city you are in, you belong to, Devendra?
Sir, Rewari, sir.
Which one?
Rewari, sir, Rewari.
Where is
Rewari.
it? Rewari?
Haryana, sir, Haryana.
Haryana. Okay.
Yes, sir.
So there may be many cities in many streets in the city. So the city name Rewali will be repeated for every street. And also the pin code of that particular city will be repeated for every street. So Rewali, what is the pin code of your city?
So 123401.
123401. So Rewali street names 123401. In Rewali, the second street name 123401. Like that, the zip code as well as the city name will be repeated for every street in the city. All right. So even though the relation is in third normal form, there is a good amount of redundancy. If there are 10 or 1000 streets in city, Rewali, 1000 times you are going to repeat the city name as well as you are going to repeat the pin code. So what can be a solution to avoid this? So here actually it is satisfying third normal form. So there is the non-key attribute. Say when you take first one as the primary key, pin code is fully dependent on city and street. Or zip code and street that determines city. Then I mean we cannot say that there is any transitive dependency. So this is in third normal. But what you can see that there are two candidate keys and they are actually overlapping in nature. And both second normal form and third normal form says that the conditions are to be satisfied or conditions are applicable only for non-key attributes. So here, strictly speaking, actually the dependence of zip code is not on the street, but it is actually on the city. So Rewali, the pin code 123401 is for the city Rewali. It is not dependent on the street, but still it is accepted. What is the reason for acceptance of that, Sunita? Villipalli Sunita.
Yes, sir.
Yeah. So what is the reason? Even though the pin code or the zip code is dependent on the city alone, you are saying that this relation is in BCNF. I mean, is in third NF. What is the reason?
There is no transitive dependency between non-key attributes, sir. Here, zip code is prime attribute of key 2.
Okay. Now, what I am asking is still there is a lot of redundancy we have seen, and transitive dependency does not come into picture because you have only 3 attributes here and the key containing 2 attributes. Okay. So here the point is that even though pin code is dependent on city alone, it is not considered as a violation of the property, I mean the clause of being in 3NF, because the dependence of pin code on city is, I mean that zip code is not a non-key attribute. It is actually part of the second key. So there is an exemption for attributes which are actually part of the keys. So actually pin code is, or the zip code is exempted from the full functional dependency condition. That is why the redundancy is coming here. All right. So the condition of full functional dependency as well as non-transitive dependency is applicable for only non-key attribute. If some attribute is found to be part of a key attribute, then it need not satisfy the conditions. And that exactly gives the reason for the redundancy present in this table. All right. Okay.
Sir, can you explain this once more, sir?
Yeah, here we find that even though city street determines the zip code, as you can see in the city street determines the zip code. Actually, the zip code is dependent, or pin code corresponds to the city. When you specify the pin code, you can find out the city. So what is happening is, even though the relation is in third normal form, there is a lot of redundancy, and it is due to the fact that the dependency of, say, the second key, if you take city, is actually dependent on, or zip code determines city. So there is a partial, I mean, actually the dependence of zip code street to city, I'm talking about key 2, zip code street determining city is not a full functional dependency,
Yes.
because city is decided, or city is dependent on zip code also, zip code alone. Without telling the street, actually the zip code is for the city and not for the street. So if you look in that way, it is not even satisfying the condition for being in second normal form. But we say this is in second, I mean, this is in third normal form, because this city is actually part of a key. So the condition of non-key attributes depending on the primary key is not applicable for city, as it is part of a key. So the condition is soft when it is coming to attributes which are part of some key. So that is actually the loophole behind third normal. Is it clear?
Yes, sir.
Okay. Now, this particular relaxation is not there in the case of BCNF. BCNF says that if at all there is a functional dependency, X determines Y, X should be the key of the primary key of the table. That is the strict condition of BCNF. So please read the lines in this particular slide. Okay, so here if you look, the original table was having three attributes: city, street, and pin code or zip code. Now, if you divide it into zip code and street, city and street, is there? I mean, this can be decomposed in two ways: zip code, street, city, street. So when you take the join, you get the original table back because street is common in both the tables. And another way of decomposing is by taking zip code and city, you decompose into zip code street and zip code city. Okay, zip code and other attributes other than city, and zip code city and zip code street. So there are two different schemes: new scheme one, new scheme two. Then there is an alternative new scheme one and alternative new schema two. So two possibilities of decomposing the table having these three columns. So here this is the first set, and here you have loss of relation. Second one you have this particular combination. So which one is actually a better decomposition? Old scheme, a new scheme one or new scheme two? Laushe, Laushe, Ekelo, Laushe. Ekelo, Laushe. Okay, absent. Keval, Keval Vaghela. Keval Vaghela. It's also absent. Lakshmi Sethi, Satya.
Yes, sir.
Yeah, which is a better decomposition scheme?
Alternate new scheme, sir.
First one or the one?
Second one, sir.
Second one. Why?
Because in the first one, we will be losing the relation zip code to city, sir. It won't be a lossless decomposition.
What you will lose?
Zip code to city functional dependency, sir.
Okay, zip code to city FD will be lost. The second
Yes.
one?
In the second one, we have the zip code to city functional dependency, sir.
Okay, that is correct. So even though both the decompositions are technically or they are not losing any data, you are actually losing a functional dependency of zip code or pin code determined city that is lost in the case of the first decomposition. All right. So read about loss of decomposition in this slide. So what Laushe has said is correct. There is a loss of information. So just read what is it in from this slide. So there are lossy decompositions and non-loss decompositions. So when you say that non-loss decomposition, it means that none of the data should be lost and none of the functional dependencies should also be lost. So in some cases, when you go for a normalization by way of decomposing the table, you may lose some functional dependencies. That will be losing the meaning of the table. Okay. So in the first decomposition, you lost the functionality that pin code or zip code determines city. That is lost. It is not coming from these two tables. But here actually you have pin code determines street, pin code determines city, and you have the pin code determining street is also there. Are you losing that functionality that pin code or zip code determines street in the second decomposition in this, which is displayed now? Mekha, is the is the rule or is the functional dependency that pin code determines city, sorry, pin code determines street, or I can say pin code determines city is there, pin code determines street is there. So what functionality is lost here?
Hello, sir.
Which functionality or which functional dependency is lost here?
Zip code
Zip code city.
to
Okay.
city.
Okay. So what is happening is here actually the decomposition is based on one direct functional dependency. Pin code determines street and actually pin code determines city. Okay. So we can say that in this case, pin code determines city is actually a transitive dependency. So you have pin code determining street and city determining street. Okay. So you are not getting the transitive dependence like city determines pin code. Okay. Anyway, when you are decomposing a table into smaller tables, do not go for transitive dependence or do not go for derived dependencies for the decomposition. So the decomposition should be done based on direct dependencies only. Derived or dependencies which are generated from other dependencies should not be used for the decomposition. Okay. Any table schema can be decomposed into a lossless way into a collection of smaller schemas that are in BCNF form. However, the dependency preservation is not guaranteed. So let us see some examples for BCNF. So please go through these examples. So there are two candidate keys in the first example. Example 2, movie title, person name, movie ID, person name. So here we have an additional functional dependency that movie ID determines movie title. So that means there is a partial dependency present in this table. Still, it is considered to be in BCN. It is considered to be in 3NF because this movie ID is actually, or the movie title is actually part of the key. So the condition of full functional dependency is applicable only for non-key attributes. Because movie title is part of the key, it need not satisfy the condition, so it goes up to 3NF. But there is possibility of redundancy in this particular design. Navani, what is the amount of redundancy? Or can you comment on the redundancy present in this table? Movie title, movie ID, person name, role, payment. What is the redundancy present? Navneet? Navneet Kaur. Suddenly Navneet Kaur also saying the mic is not working. Okay, you can type the answer on the chat box, Navneet. Please type your answer on the chat box. What is the amount of redundancy present in this table? If you cannot answer, please type there. Four of D, there is a redundancy. Four of D. What do you mean by 4 of D? Navneet, what is 4 of D? Okay, Navneet. Fourth functional dependency. There is nothing like fourth functional dependency. Okay, this one, you are saying that movie ID, movie title. All right. Okay. Okay, so functional dependency and redundancy are very much related. So what the point here is that when there are more than one candidate key and when the candidate keys are overlapping in nature, these 3NF fails in removing the redundancy. In that such context, people introduce BCNF, and BCNF is found to be successful in situations where there is more than one candidate key and the candidate keys are overlapping in nature. What is the condition for a relation to be in BCNF? Rahul Moharana. What is the condition for a relation to be in BCNF? His mic is also not working or is not there. Rahul Soni.
Am I audible?
Yes.
Yes, sir. What? Can you repeat question again? What is the condition for BCNF? Is it?
Yes. Yes. Yes.
Sir, in BCNF, every non-prime attribute depends on prime attributes, and the prime attributes actually candidate keys on the prime attribute side does not have more than one column.
More than one column. There
Yeah,
can be composite key.
on the functional dependencies on the left hand side, there should not be more than one column as a prime attribute or as a candidate key in
You
BCNF.
mean there cannot be any composite keys?
Yeah, sir.
Like say movie ID, person name, there cannot be a key. Is it so?
No, sir. It can be a key, but it should any non-prime attribute must not only depend on a composite key.
That is not correct, Rahul.
Sir, BCNF does not allow dependency between the prime attributes, uh, which belongs to some composite key.
Okay. So the condition for a relation to the BCNF is that for any functional dependency of the form X determines Y, X should be the candidate key of the table. So that is the simplest and the strongest definition that is possible for BCNF. For any functional dependency of the form X determines Y existing in the table, X should be the key of the table. If you can decompose the relation in such a way that for every functional dependency X determines Y, X comes as the key of the table, then it is said to be in BCNF. So it is a very good and a very attractive scheme for removing redundancy. All right. Now, there are certain cases where actually I have that example here. There is condition for full functional dependency, non-transitive dependency, and non-transitive dependency. Everything is satisfied, then still there is a lot of redundancy. For example, let us assume that you have a table with 3 columns: course, teacher, and textbook. Okay, so let us say alpha stands for course and beta stands for teacher, or let us say course, teacher, and textbook. So a course can be taught by many teachers. So let us say the course of database management system or topics in that DBMS can be taught by 5 teachers. And there are 10 textbooks for topics in database design. So you will have instructor A or teacher A referring, teaching the course by taking a particular textbook. There is no restriction on the textbook that a teacher can refer. So you have many rows in the table corresponding to every textbook that the teacher is referring. So assume a table course, teacher, textbook. There are many courses and there can be many teachers offering the same course, and there can be a textbook, multiple textbook for the course, and the teacher may be referring any of these textbooks. And a textbook can also be used as a textbook for more than one course. Okay, let us assume that you have these 3 columns: course, textbook, and teacher, and there is no functional dependency among these 3. That means when you say the course name, topics in database, you cannot say who is the teacher, because there are 3 teachers offering the course. When you say topic in database, you cannot say who is the instructor, because there can be more than one. And when you say the textbook, you cannot say which is the course, because the textbook can be used for many different courses. And when you say the textbook, you cannot say the teacher, because many teachers may be using the same textbook. So assume that there is such a table, course, teacher, textbook. In which normal form this table is in? The one that I am describing now, Sahil. Or what is the functional dependency of this table? Course, teacher, textbook. Multiple courses.
Sir, it's not in first normal form.
Yeah, of course it is in first normal form. Or what is the key for this table? Course, course name, teacher name, textbook name.
Course name, sir.
But if you say the course name, you cannot say the teacher name, Sahil. Or if you say the course name, you cannot tell the textbook name. So what is the key?
Sir, then all 3 must be the part of the key.
Okay, so course, teacher, textbook combinedly act as the key of the table. All right. So see, course, I mean, it is actually a whole key relation. All the attributes are forming part of the key. Now, The thing is that there is only one functional dependency. Course teacher textbook determines course teacher textbook. So it satisfies all the conditions of first normal form, second normal form, third normal form, and even BCNF. But are there any redundancy present in such a table containing course data? Sarita? Sarita?
Yes, sir.
Yeah. What are the redundancies present in this table?
One course may be connected to many features.
Connected to many?
Features
Okay.
and many textbook.
Okay. So
And
what is
one
the redundancy? Santosh Kumar? Santosh Kumar. Ria? Santosh is also absent. Ria?
Hello, sir.
Yeah. So what is the redundancy present in this table? We have seen that this is in BCN, course teacher textbook. There is only one FT, functional dependency, course all key relation. Course teacher textbook determines course teacher textbook.
Course teacher textbook. Yes, sir.
What is the what are the redundancies present in the table?
Sir, teacher to course and teacher to book.
Means what?
So functional dependencies from teacher to book, there can be redundancy, and from
There is no functional dependency. If you say the teacher name, you cannot say the course name,
yes.
isn't it?
Yes,
The
sir.
teacher may be teaching many courses.
Many courses, and so for the same course, there can be many textbooks,
Yeah.
and so there can be redundancies, sir, for the same course, and the teacher can refer to many textbooks.
Yeah, but you cannot list all of them in a single row. I mean, single column according to first, then it will violate first normal form.
First normal form, yes, sir.
I cannot write topics in database design, say taught by Gopakumar, and then I should not write all the textbook names separated by comma. Then it will not be even in first normal.
First normal form, yes, sir.
So here the thing is that suppose there are 10 textbooks for a course, then you have to repeat the course name for every textbook
That
name.
is thoughts. Yeah.
And you have to repeat the course name. Yeah, then you suppose there is a teacher referring 5 books for a course. So the teacher name and course name are to be repeated for all those 5 books. Say for topics in database design, I am following 10 textbooks. So for each of those textbooks, you have to repeat the course name, topics in database design, and you have to repeat my name. So there comes that many number of rows. So it is there is a lot of redundancy even though the relation is in BCNF. All right. So here is actually a situation where even the concept of functional dependency fails. So here you don't have something like X determines Y, but what you are having is X multi determines Y, or alpha multi determines beta. Corresponding to every alpha, there is a set of beta. Okay, and corresponding to every alpha, there is a set of alpha R minus alpha minus beta. So corresponding to X, there is not a single instance of Y. but there can be multiple instances of OI. So that is actually what is, a situation or such cases, you generalize FD into something called MVD, multi-valued dependency. There are multiple values. Corresponding to every X, there is a set of Y. So multi-valued dependencies, MVDs, are used in two ways. To test the relations to determine whether they are legal under a given set of FDs and functional multi-valued dependencies. Then, to specify constraints on the set of legal relations, we shall thus concern ourselves only with relations that satisfy a given set of FD and multi-value dependencies. If a relation R fails to satisfy a given MVD, we can construct a relation R dash that does not satisfy the multi-value dependency by adding tuples to R. Okay. Suppose you have a relation R which fails to satisfy a given FD, we can construct a relation R dash that does satisfy the MVD by adding tuples to R. Okay, so the fourth normal form is actually defined based on multi-valued dependency. So the concept of functional dependency fails after BCNF. So there you generalize FD and introduce something which is known as MVD. So the fourth normal form eliminates independent many-to-many relationship between columns. Okay, a teacher taught by teaching many courses and a course being taught by many teachers, such things are avoided. So to be in fourth normal form, a relation must be in BCNF and a given relation may not contain more than one multi-valued attribute. Okay. So I can say that for any multi-value dependency of the form X multi-determines Y, X should be the key of the table. Then you say the relation is in BCNF. For any functional dependency or a multi-value dependency of the form X multi-determines Y, X should be the key of the table. Then you say that the relation is in fourth normal form. Okay. We will see more about 4NF in the coming class. All right. So 4NF is the concept of functional dependency is valid only up to BCNF. Thereafter, the BCNF, functional dependency cannot tell you about the redundancy. So you introduce something which is known as multi-value dependency. So when the multi-value dependency also fails, you go to the next level of dependency form, which is called the joint dependency. All right. Okay, I will be uploading the project topics along with the names by today night. So check by today night the topics that are allotted to you, and you can start working on the projects. I think few are left out. They will be having individual projects, and others will be given. 2 people will be working on the topics on that same topic. So we have around 25 different topics available. All right. So please check the website.